In this video, we're going to study set operations. Union. The union of two sets A and B, denoted by A union B, is the set of all objects that are elements of either A or B. Okay, let's have examples. Suppose, for example, we have set A containing the elements 0, 1, 3, 5, and 7. And set B contains the elements 1, 2, 3, 6, 8, and 9. So what are the elements of A union B? Okay, so here the elements of A union B are all elements of set A or elements of set B. Okay, so first let's list all the elements of set A: 0, 1, 3, 5, 7. And then next, we are going to list the elements of set B that are not in A to avoid repetition of elements. So we're not going to list 1 because it's in A already. We have 2. 3 will not list 3 because it's in A already. Then next is 6. Then 8. Then 9. Okay, the elements of the result of the union of set A and set B can easily be seen in a Venn diagram. So let's try placing the elements in our example in this Venn diagram. So first we are going to list the common elements of both sets. So observe that 1 is in A and at the same time it's also in B. So another 3 is an element of both A and B. What else? Oh, only 2. Okay, so the rest of the elements are elements of A only. So we have 0, 5, 7. Okay, there are 1, 2, 3, 4, 5 elements. Let us check 1, 2, 3, 4, 5. Okay, so we have 0, 1, 3, 5, and 7. While set B contains the elements, we have 1, we have listed it already here, then 3, then let's list the elements of set B that are not in A. We have 2, 6, 8, and 9. Then let's count the number of elements in set B: 1, 2, 3, 4, 5, 6. And then here inside the circle, 1, 2, 3, 4, 5, 6. And let's check if we have listed the correct elements. Elements of set B are 1. We have 1 here inside circle B, 2, 3, 6, 8, and 9. And it's very clear that the elements of A union B are all elements that are inside the regions that belongs to A or to B. So we have 0, 5, 7, 1, 3, 2, 6, 8, and 9. So these elements are just the same with the elements in our example. Okay. The only difference is the order. Okay, so here, so in this Venn diagram, we can illustrate the result of the union of set A and set B by using shading. We're going to shade the appropriate region here in the Venn diagram that is the result of the union of set A and set B. So S sub 1 is a region of set A. This is part of the union. Then S sub 2, the region for both A and B, and S sub 3, the region for B but not A. So S sub 1, S sub 2, and S sub 3 illustrates the result of the union of set A and set B. Okay, so let's proceed to the next operation. We have to erase everything first here. Okay, the next operation is intersection. intersection. The intersection of two sets A and B, denoted by A intersection B, is the set of all objects that are elements of both A and B. If two sets A and B have no common elements, then the two sets are said to be disjoint. The intersection of disjoint sets is the null set. Okay, let's have examples. Suppose the elements of set A are 0, 1, 2, 4, and 5. And set B contains the elements 0, 2, 3, 5, 6, and 7. Now, what are the elements of A intersection B? Okay, so to determine these elements, we're going to look for common elements of both A and B. Now, observe here that 0 is common to set A and set B. So 0 is one of the element of the intersection. Another common elements, we have 2. So another element of the intersection is 2. Another common elements, we have 5. Okay, what else? So there are only 3 common elements of both set A and set B. So these are the elements of the intersection of set A and set B, 0, 2, and 5. Now, okay, let's have another example. Suppose we have set C containing the elements 1, 2, 3, and 6. And we have set D contains the elements 0, 4, 5, 7, and 8. Now, what are the elements of C intersection D? Okay, see, so here we are going to look for common elements. Are there common elements of set C and set D? Okay, observe that there are no common elements. Okay, so since there are no common elements, these two sets are said to be disjoint. Okay, disjoint. And the intersection of disjoint set is the null set, or you can use this notation since there are no common elements. Okay, now let's try placing the elements in our example in a Venn diagram. Okay, let us make a Venn diagram here. Okay. Okay, Venn diagram. Okay, so we have the universal set, the rectangle, set A, set B. Now in our example, what are the common elements of set A and set B? We have 0, 2, and 5. And other elements that belongs to A only but not B. We have 1 and 4. And then what are the elements that belongs to B but not in A? We have 3, 6, and 7. Now let's check the elements of set A. We have 0, which is inside circle A, 1, 2, 4, and 5. And the elements of set B are, we have 0, 2, 3, 5, 6, and 7. Okay, so what are the elements of A intersection B based on the Venn diagram? Okay, it's very clear. Okay, so observe here that the two circles A and B overlap at this region. So this would mean that this region is common to the two sets. So therefore, the elements are 0, 2, and 5. These are the elements of the intersection. It's just the same with the elements in our example. Now, so therefore, uh, how are we going to show the result of the operation A intersection B using using shading of a Venn diagram? Okay, so let's draw first two overlapping circles here. Okay, so we have here set A, set B. So A intersection B. Now we have here S sub 1, S sub 2, S sub 3, and S sub 4. Now what region of the Venn diagram represents the intersection of set A and set B? And we're going to use a color to shade the correct region here. So here we have S sub 2. So S sub 2 is the region in the Venn diagram that shows the result, or that illustrate the result of the intersection of set A and set B. Okay, now this time let's proceed to the next operation. Next operation. Okay, okay, the next operation is difference. Okay, difference. The difference of two sets A and B, denoted by A minus B or A slash B, is the set of all elements that belong to A but not to B. This also referred to as the relative complement of B with respect to A. Note that for the operation A minus B, B does not have to be a subset of A, or B can contain elements that are not in A. Let's have an example. Suppose, for example, we have set A containing the elements 0, 2, 3, 5, 7, and 8. We have set B containing the elements 1, 2, 4, 7, 8, and 9. So what is A minus B? Okay, so we recall that A minus B means A only, or A but not B. So let's take note of these two keywords, only and but not. Okay, so here we are going to list the elements that are in A but not in B. Okay, so what are the elements of A but not in B? So we have here 0, 3, 5, oh, 0, 3, and 5 only. Or another concept is, we recall that the meaning of difference is take away B from A. So here, observe that if you are going to take away the elements of set B from A, so 2 is taken away, 7 is taken away, and 8 is taken away. So what are the elements that are left? These are 0, 3, and 5. Okay. So okay, let's have another example. Okay. Suppose set A contains the elements 1, 3, 5, 2. And set B contains the elements 0, 6, 3, 5, and 7. What are the elements of B minus A? Okay, so here we are going to list the elements of set B only, B but not A, or take away the elements of A from set B. So take away 3 from B, take away 5 from B. So what are the remaining elements for set B? We have 0, 6, and 7. So therefore, uh, the result of the operation B minus A are the elements 0, 6, and 7. Now the result of this operation can also be shown using a Venn diagram, or in a Venn diagram. Now let's try uh, examples wherein we are going to list the elements inside a Venn diagram. Okay, suppose set A containing the elements 0, 2, 3, 8, 9, and we have set B containing the elements 1, 2, 4, 8, 10. Okay, so let's construct first a Venn diagram. Okay, Venn diagram. Okay, we have here the universal set, set A, set B. Okay, let's try listing the elements of set B. What are the elements of set B? We have 0, 2, 3, 8, and 9. Let's look for common elements of set A and set B. We have here 2 and 8. Then, okay, so what are other elements of set A that are not in B? We have 0, 3, and 9. Let us check if these elements are already all the elements of set A. We have 0, 2, 3, 8, and 9. What about set B? What are the elements of set B? We have 1, 2, 4, 8, and 10. Now, since we have listed already 2 and 8 here, so other elements that belongs to B only are 1, 4, and 10. Now let's check all the elements of set B. We have 1, 2, 4, 8, and 10. Now, based on the Venn diagram, what are the elements of A minus B? A only. A but not B. So what are the elements of set A but not elements of set B? We have 0, 3, and 9. So another meaning, take away set B from set A. So the remaining elements are 0, 3, and 9. What about if the problem goes this way? B minus A. So what are the elements of B minus A? B minus A means B only, while A minus B means A only. So what are the elements of B only? We have here 1, 4, and 10. So elements of B but not A. Okay, let's have a shading now in the Venn diagram. I'm going to show another Venn diagram here, which is already the result of difference using shading. So let me construct first the Venn diagram here. Okay, so this is the universal set, set A, set B. We have S sub 1, S sub 2, S sub 3. Now we have here A minus B. Now what region in the Venn diagram represents the result of A minus B? And we're going to shade it. Okay, so here the result is the region which is the result of A minus B is S sub 1. Okay, let's color this in blue. So this is the region which is the result of the operation A minus B, S sub 1. Okay, so let's proceed to the next operation. Let's erase everything here. Okay, the next operation is complement of a set. Okay, we have complement of a set. Okay, complement of a set. The complement of a set A, denoted by A prime or A bar or simply A to the C or A complement, read as A prime or A complement, is the set of all elements in the universal set that are not in A. Example here, if A is equal to a set containing the elements 1, 2, 3 and the universal set is the set containing the elements 0, 1, 2, 3, 4, 5, and 6, then A complement is equal to the set containing the elements 0, 4, 5, and 6. Okay, so aside from this example here, let's try another example. I'll give you another example. Suppose the universal set contains the elements 0, 2, 3, 4, 5, 6, 7, 8. And we have set A contains the elements 2, 4, 6, and 7. Now, what are the elements of A complement? Okay, the elements of A complement are the elements found in the universal set that are not in set A. Okay, so we have an important keyword for complement. Complement means not. So not A. Not A. So not an element A, but element of the universal set. So what are the elements of the universal set that are not elements of A? We have 0, 3, 5, and 8. Okay, because these 2, 4, 6, and 7 are elements of A. So therefore, the elements of A complement are 0, 3, 5, and 8. Because again, these are elements found in the universal set that are not found in set A. Okay, so I am going to show you a Venn diagram. Let's try constructing a Venn diagram. Okay, let's try. Okay, let's try placing the elements in our example here inside the Venn diagram. Now, what are the elements of set A? We have 2, 4, 6, and 7. So this circle represents set A. And the rectangle is represented by the universal set. And what are the elements of the universal set that are not in A? We have 0, 3, 5, and 8. Now, if we will check all the elements of the universal set are all elements inside the rectangle. We have 0, 2, 3, 4, 5, 6, 7, and 8. And the elements of set A are 2, 4, 6, and 7. Okay, so therefore, if we are going to use or show shading in a Venn diagram as a result of a complement, this is how the Venn diagram looks like. Okay, so, let's draw a circle here. Okay, suppose this is the universal set and this is set A. This is S sub 1 and this is S sub 2. Now, what region of the Venn diagram shows the result of a complement, and we are going to shade it. A complement. Okay, so the region that represents a complement is S sub 2. So this is the region of the universal set that is not region of set A. So outside circle A, but inside the rectangle. Okay, that's it.